Hello students, here in this video we will see the introduction of computer aided machine drawing laboratories. First of all, let's see the course objectives. First one is to make the students understand and interrupt drawing of machine components. To prepare assembly drawing both manually and using standard CAD packages. To familiar the students with Indian standards on drawing practice and standard components. To gain practical experience in handling 2D drafting and 3D modeling software systems. List of experiment. In the syllabus, they are divided into three parts. First of all, drawing standards and fits and tolerances. And second one is introduction to 2D drafting. And third one is 3D geometric modeling and assembly. They are divided in three parts. This is the basics. First one is basics of engineering drawings, standards, and components. Okay, and second one is introduction of 2D drafting. 2D drawings, dimensioning, layering, hatching, blocks, detailing, is everything. And third one is geometric modeling and assembly. This is the 3D modeling softwares. Uh, Here in this laboratory, you will use the AutoCAD software for 2D and 3D purpose. Okay. First of all, drawing, describing any object or information diametrically. This is called a drawing. Engineering drawing, graphical means of expression of technical details without barrier of the languages. Universal language of for engineers. Drawing is the one of the language which is used in engineers, which is the universal language of engineers. Okay. As a mechanical engineer, drawing is very important for your career. Diagrams, sketches, pictures, communication skill. Okay. We grasp information easily if it is illustrated with diagrams, sketches, pictures, etc. LCA, the world smallest lightweight multi-role supersonic compact aircraft of the world. This is the smallest aircraft. Okay, and this is Airbus A330. Largest passenger jet. This is the largest passenger jet. 80 wingspan and tail that stand a high as a seven-story building, carries more than 550 passengers. Okay, it will just be impossible to communicate all necessary details about the LCA and Airbus A380 verbally in a writing. Okay, but illustration or picture drawing is very useful to explain all the details about this exam about this aircraft. Okay, a picture or drawing is worth 1,000 words. Okay, the LCA Airbus would be impossible to create without computer graphics and drawing models. Drawings are the roadmap which shows how to manufacture product and structures. This is the civil structure. This is the building structure. It is also impossible to describe the details of the building. Okay, without the picture, we cannot describe the about this picture. Okay, this is the machine. This is the lathe machine. Difficult to describe the details of this machine. This is also machine. In welding, we cannot describe the machine. Okay, this is the chemical reactor. This is the actual chemical reactor. This is the drawing. Here also we cannot describe the chemical reactor without drawing. Okay, in words. This is the electrical circuit. So Drawing is important for all branches for engineers. Drawing is very essential for all branches: mechanical, civil, electrical, electronics, and so on. Okay. Drawing is the graphical representation of the object. Engineering drawing, a drawing of the object that contains all information. In engineering drawings, which is contain the all information, shape and dimensions, dimensional constraint and geometrical constraint, like actual shape, accurate size, manufacturing methods, etc. required for the construction. No construction manufacturing of any man-made engineering object is possible without engineering drawing. Okay. Engineering drawing is classified into two parts. One is manual drawing, other one is computer aided design and drawing, drafting. Okay. CAD. Computer has a major impact on the methods used to design and create technical drawing. Design and drafting on computers are cheap and less time consuming. Okay. Comparatively, manual drawing, computer design, and drafting is the very cheap and time consuming process. In manual process, it will take more time and documents and drawing sheets and etc. Okay. But why we go for manual drawing? Okay. Why we go for manual drawing? Why? Because manual drawing is a very basic things. Okay, without knowing the basic things, we cannot go for the next level. For example, up to 12th standard, we are using simple calculations with using the max formulas, adding, subtraction, and everything. Again, you come to the college, you will use the scientific calculator. This is the computer aided thing. Before the up to school level, you are using and simple calculation using the pen, pencil, and mathematics formulas and everything. Uh, Likewise, basic is manual drawing and computer aided is the advanced thing. Okay. First you may know the manual things. Okay. That's what you are studied in first semester in engineering graphics using drafters and pencils and different types of lines and different types of projections of line points and everything. Okay. Uh, Standards and conventions. Standards and conventions. No effective communication without an agreed upon standards of science or symbols. The standards and conventions are the alphabet of technical drawing, and plain, solid, and descriptive geometry are the science or grammar, which underline the graphics languages. Okay, standards are used to underline the graphics languages. Following the standard rules, grammar of any languages, Hindi or English, communication of the through between the people become easier. Okay, if word in the sentence were presented randomly, understanding become very difficult. For effective communication of the technical or graphics information, set up standards and conventions a must. Okay, so standard and convention is very important. Without standard and convention, you cannot read the engineering drawing. It is like a grammar. Okay, convention, commonly acceptable and practice rules or methods. Here the drawing on simple drawing is the this is the front view and top view. Here dash cut lines are used to represent the hidden. Okay, dash lines are used to represent the hidden features of the engineering drawing. Okay, you have studied about the different types of lines. Okay, a continuous line, center line, and dashed line. Okay, zigzag line. Like that, you are studying in engineering graphics. You may refer your books also. Okay, this is the hidden line, which is used for hidden object. Okay, Here, hidden lines located for the drill holes diameter. Here in this front view, here in this top view, here on drill is there, and in this front view, we cannot see the drilling. Okay, only we see the this dark lines only. We cannot see the uh, drilling. For this purpose, you will use the dashed line to represent the hole. Okay, the location of the drill holes diameter in a view where the hole cannot be directly seen. Okay, standards set up rules that ground how technical drawings are represented. Okay, this is the technical drawing which they are using in industries. Okay, they are this is the standard drawing. This is the drawing and dimensioning and the geometrical tolerance and the GD&T. Okay, and different types of lines are used here. Dash lines and the center lines. Okay, that sectional view projections. Okay, everything and lettering. Okay, everything they are used here. Drawings are dimensioned used on accepted set of standards such as the placing the dimensions text such that it is read from bottom of the sheet. Okay, a drawing standard. Some of the standards followed in worldwide. Okay, first of all, ANSI, American National Standard Institute. Okay, ANSI Y 14.1 1980 revised 1987. The drawing sheet size and format. This standard is represent the drawing sheet size and formats. And so ANSI Y 14.2 M 1979 revised 1987. Line convention and lettering. This is represent the line convention and lettering, different types of lines and lettering dimensions. Okay, ANSI Y 14.5 M 1982 raised 1988, dimensioning and tolerancing. Okay, likewise ISO, International Standard Organization, JIS, Japanese Standards, and BIS, Bureau of Indian Standard. Like that, different types of standards are followed in worldwide. Okay, these are the standards which is represented the engineering drawing. Units, next of all, unit of measures. In International System of Units, SI, which is based on the meter. And this is SI unit is based on meters. Millimeter, the common SI unit of measure of engineering drawing. Millimeter is mostly used in Indian countries, mostly used in millimeter. In abroad and western countries, they are used in inches. Okay, uh, individual identification of linear unit is not required if all dimensions on the drawing are in the same unit millimeter. For angle, you are using the degree. Okay, for linear dimension, you are using here millimeter only. Okay, the drawing cell, however, contain a note of all dimensions are in mm, bottom left corner outside of the title box. You are used in engineering graphics also for this standard. Okay, dimensioning. How importance of dimensioning? Indicating on a drawing the size of the object and other details essential for its construction and function using line, numerical sorry, numerical symbol notes and etc. Dimension indicates the drawings should be those that are essential for the production, inspection, and functioning of the object and should not be makes should not be mistaken as those that are required to make the drawing of an object. These are the standard codes are using in SI, IS Indian Standard 9609 1983. which is represent the lettering and technical drawing. Okay, this is the Indian standard using in India. Okay, lettering and technical drawing, size of the drawing sheet, like that we are seen in ASNI, ANSI standard. ANSI Y 14.1 1980. This is represent the drawing sheet size and format. This is using for line conversion and lettering. Like that SI unit. This is the IS unit, Indian Standard Unit. Okay. Scale for use of technical drawing. General principles of presentation. Okay, rules of presentation, offspring, folding up drawing, print, technical drawing, title block, which are the standards we are used in India. Next one is basics of welding symbol. This is the welding symbol which we are used in welding. Okay, this is the arrow. This is the symbol. Okay, this is the reference line. Okay, arrow line. This line indicates the where the weld need to takes place. Okay, the symbol is used for there are different symbols for each type of weld joint. This area indicate the weld to be used. This is the reference line. This is the where all the information is set out to complete the weld. Okay, this data dashed line is under the reference line, indicates which side of the fair side. Okay, let's see briefly in next slides. Okay, this is the weld symbols. This is the arrow line, this is the reference line, this is the other side, this is the arrow side. Okay, let's see here. Yeah, the weld symbol, this is the weld symbol. Okay, this is the arrow. The symbol is the weld symbol is located in top of the reference line. Okay, top of the reference line. So which is located in top of the reference line that indicate the other side of the arrow. This is the arrow side, this is the other side of the arrow. So this is the reference at the other side. Okay, here the symbol is downward. Okay, this is the arrow side, so arrow is this side. So welding to be conducted, welding to be made in arrow side. This is here welding to made on opposite side. Here the symbol is both side, so both side we should weld. Okay, this is the welding symbol. Different symbols are there. See, this is the welding symbol. This is the arrow side, this is the arrow. The symbol is in top of the reference line. So it is reference line which is indicate the opposite side of the arrow, opposite of the arrow side. So they are welded in opposite side. Here this symbol is indicate the both side weld. So here they were welded in both side. Okay, uh, this is weld symbol. Is the symbol plus the extra one parallel line are represented here. So it is indicate the flat weld. Okay, this is see, let's see the flat weld. This is indicate the convex weld. Okay, this is indicate the convex weld. Okay, let's see convex. Okay, then next this symbol is indicate the concave. Okay, this is indicate the concave. Then let's see the list. This is a supplementary weld symbol. Okay, field weld, site weld. Okay, this is the NDT, the component required to NDT inspection. For this, this is the weld to be carried out all round component peripheral weld. Okay, in for pipeline, which symbol is used, and additional information. The reference document is included on the box. Okay, additional information is indicated in this box. Okay, the next one is Well, welding symbols and dimensions. Okay, here this is the welding area. Where this distance is A, this is the distance is B. A is the distance through thickness, and B is the leg distance. This is the leg distance, and here generally A is the zero point 0.7 times of B. Okay, here this A is the zero point 0.7 times of B. Okay, let's see here, which is indicate A4. That means 4 millimeter through. Okay, this distance is 4 millimeter. Here this is the B6, 6 millimeter through. Okay, throat and leg. Okay, this is the throat distance. This is the leg distance. The next welding symbol and dimension, here which is indicate the n x n into L in bracket E. Okay, here n is the number of weld element, L is the length of each weld element. Okay, and E is the distance between each weld element. Let's see here, 3 into 40 into sorry, in bracket 50. So that means in opposite side 3 weld. Okay, 1 2 3 weld in the distance of 40 millimeter, and distance between the weld is 50 millimeter. Okay, this means opposite side well, arrow side, this is not the arrow side, opposite side of the arrow side. Okay, this is three elements, one two three elements, and each weld is weld distance is 40 millimeter. See, let's see, this is the 40 millimeter, and the distance between each weld is 50 millimeter. Okay, let's see. And then here 2 into 40. Yeah, this in welding, I mean arrow side is 2 weld. Okay, 2 weld at the distance of 40 millimeter, and difference between the two weld is, distance between the two weld is 50 millimeter. Okay, the next one is, this is the welding symbols, other welding symbols also. This is the single V butt weld. Okay, the symbol is indicate the single V butt weld, and this symbol is indicate the single U butt joint, and this weld is indicate the, okay, single V butt plus cap. Okay, here after the weld the surface is flattened. Okay, here the convex shape is there. Here after the weld it will be grounded, and this symbol is a single U butt with sealing rod. Okay, these are the different welding symbols. And also this also different symbol. This indicate the single bevel butt. This is the single bevel butt. This is the double bevel butt joint, and this is single bevel butt joint. This is opposite side, and this is single J butt joint. Okay, and this is welding symbol also. Uh, particle presentation single V butt joint. Okay, this means the height of the weld is, the welding area is 10 millimeter. Okay, this indicate the height of the weld is 10 millimeter. Okay, the other welding symbols, this is indicate the plug welding and square butt weld and spot weld, single V butt boat root face, seam weld, H flange weld. And next one is limits, tolerance and fit. Let's see one by one. Limit, maximum and minimum permissible size within which the actual size of the component lies. Okay, a limit is nothing but maximum and minimum permissible size. Okay, tolerance is the, it is impossible to make anything to an exact size, so it is essential to allow the Definite tolerance or permissible variation on every specified dimensions. Tolerance is nothing but closer to the true value of the actual size of the component. Okay, fit. Uh, it is on a assembly condition between hole and shaft. Okay, let's see one by one. Um, no two parts can be produced with identical measurement by any manufacturing process. We cannot, at any cost, we cannot make a component identical with the same shape and same dimensions. We cannot make. Okay, for that purpose, in any production process, regardless how well it is the designed and how carefully it is maintained, a certain amount of variation, I mean that is natural, will always exist. Okay, some certain amount of variations should be there for manufacturing the product. Okay, we cannot make the product identically with the dimensions, same dimensions and same shape. We cannot make. Some minute negligible difference will be there. Okay, variation arise from importantly adjacent machines, operator error, tool wear, and defective raw material, etc. Okay, such variation are referred as a uh, assignable causes and can be identified and controlled. It is impossible to produce a part to an exact size or base size. Okay, some variations known as tolerance need to be allowed. Okay, the permissible level 2 tolerance depends on the functional requirement which cannot be compromised. No component can be manufactured precisely to a given diameter or dimensions. It can only be made to lies between two limits, that means upper limit and lower limit. Uh, and designer has to suggest this tolerance limit to ensure satisfactory operations. The difference between the upper and lower limit is termed permissible tolerance. Permissive tolerance. For example, a shaft has a manufactured to a diameter of 40 plus or minus 0.02 millimeter. The shaft has a base size of 40 millimeter. Here, the base size is 40 millimeter. It will be acceptable if it is diameter lies between the limit of the size is upper limit is 40 plus 0.02, that means 40.02 millimeter, and lower limit is 40 minus 0.02, that means 39.98 millimeter. So the permissible tolerance limit is 0.04 millimeter. Okay, then permissible tolerance is equal to 40.02 minus 39.98. That means 0.04 millimeter is the tolerance limit of this object, the shaft material. And tolerance, the algebraic difference between the upper and lower acceptable dimensions, that is called the tolerance. It is the absolute value. The basic purpose of providing tolerance is permit dimensional variation in manufacturing of component, uh, othering of performance criteria. Tolerance, classification of tolerance. Tolerance are classified in four category: unilateral tolerance, bilateral tolerance, compound tolerance, and geometric tolerance. First, let's see the unilateral tolerance. Limits indicate the upper and lower limit of the tolerance. Unilateral tolerance means in any one direction. Okay, the tolerance extend in only one direction. Here let's see either plus or minus. Okay, here let's see, this is the unilateral tolerance 14 sorry 1.498 in minus 0.001. Okay, either plus or minus. This is called a unilateral dimension. Limit allowances is nothing but they were fixed in limit 1.98 to 1.97 497. This is limit. Within this limit, this dimension should be there. Okay, and bilateral tolerance means the tolerance extended in both direction. That means plus or minus. In both direction they are giving the uh, tolerance limit. Okay, this is called a bilateral tolerance. And compound tolerance, that means let's see the diagram. The tolerance of the dimension r, this is the tolerance of the dimension r is determined by combined effect of, this is the determined by combined effect of tolerance of 40 millimeter diameter plus on 60. Okay, this is the combination of 40 millimeter diameter here plus or minus 0.02, and here this angle is 60 degree, which is also plus or minus 2 degree. Okay, and 20 diameter and 20 plus or minus 1, which is this R is uh, represented by this three dimension. Depending on three dimension only, this R will uh, get. Okay. Next one is geometric tolerance. Geometric dimensions and tolerances. It is called a GD and T. Is method of defining parts based on how they function using standard symbols. And these are the symbols we are using in the GD&T, geometric tolerance and symbols. Okay, the symbols are classified in five category tolerance types. One is form, second one is orientation, and the third one is location, and run out and location. Okay, these four categories only: form, orientation, location, and run out. Okay, first one is form, which is the flatness, straightness, simplicity, and circularity. Okay, and orientation is perpendicularity, parallelism, and angularity. This is the simple. This is the geometric characteristics. And location is position, profile of the surface, profile of the line, and total runout, circular runout, concentricity, and symmetry, which are the symbols used in the drawings in engineering drawings. Uh, These are all symbols are used to constrain the drawing in a geometrical constraint. These are the symbols are used to constrain the geometrical constraint, the flatness, straightness, and simplicity. Okay, let's see. This is a drawing. They are using geometrical tolerance. Okay, these three box and four box are used here, and first box is represent the. This first box is represent the uh, simple of the operations. Okay, and this symbol is indicate the what is this symbol. This is concentricity. Okay, this symbol is concentricity, which is represent the this two cylindrical object which both are in the same axis line. Okay, which is represented here. Okay, next one is center box. This is the center box which is represent the tolerance value. Okay, tolerance values dia dia 0.01 millimeter, and third box is represent the reference of next value. Okay, indicate the tolerance between the tool cylinder. Center cannot be apart from more than 0.01 millimeter. Okay, the center should not exceed the both center of the object should not exceed the 0.01 millimeter, which is the reference center. This is also called a geometrical tolerance. This is the example. This is actual engineering drawing. Here used in uh, geometrical tolerance. This is the location and diameter value, and this is called uh, maximum material condition, minimum material condition. This is the maximum material condition, and A, B, C are the datum of the other side. This is the datum line, datum B, and datum C, and datum D, datum A. Okay, this is the called geometrical dimensioning and tolerancing symbols. And next one is fit. What is fit? The degree of tightness and looseness between the two mating parts. To assemble parts, degree of tightness and loosen between two mating parts. This is called a fit. Three basic types of fit can be identified. Okay, depending on actual limit of the hole and shaft. Okay, it is classified in three category, three types. One is clearance fit, and next one is interference fit, and the third one is transient fit. Okay, let's see one by one. First one is clearance fit. The upper limit of the shaft is less than the lower limit of the hole. Okay, this is the upper limit of the shaft. This is the lower limit of the hole. Okay, here the upper limit of the shaft is less than the, this is less than the, this is the upper limit of the shaft is less than the uh, lower limit of the shaft. Okay, so the clearance between the shaft outer diameter and the whole inner diameter is more. Maximum clearance is here we can get the maximum clearance. The largest permissible dia of the shaft is similar, shaft is smaller than the diameter. So the shaft is smaller than the hole diameter. Okay, of the smallest hole. Okay, so shaft rotating in the bush. Okay, so for this, in this fit, the shaft is freely rotate or sliding over the circular hole. Okay, this is called a clearance fit. And next one is interference fit. Here the upper limit of the hole is less than the lower limit of the shaft. The upper limit of the hole, this is the hole, the upper limit of the hole is less than the lower limit of the shaft. Let's see here. So we can get the clearance is very minimum interface, minimum clearance only we can get. Here, let's see the minimum interface. Okay, so here the maximum interface we can get the maximum clearance. Sorry, this is the maximum clearance we can get. Here the minimum clearance we can get. So the no gap between the face and the intersecting material will occur. So no gap between the shaft and hole. Okay, uh, that means shaft shaft is little bit more than the hole, I mean hole diameter. So shaft need to additional force to fit in the hole. Okay, so we can use additional force to fit in the hole. Okay, this is called interference fit. And next one is transition fit. Okay, diameter of the large permissible hole is greater than the dia. Okay, the hole is uh, greater than the diameter of the smallest shaft. Okay, here largest this dimension is, I mean upper limit of the hole is greater than the upper level of the shaft. So this clearance only we can get. Here, neither loose or tight, like clearance fit and interference fit. It may be sometimes depending on the tolerance, it may be loosen or tight. Okay, tolerance zones of the shaft and the hole is will be overlapped between the interference and clearance fit. Okay, which is the intermediate of clearance and interference fit. Okay, this is called a transient fit. And next one is preparation of production drawing and reading of part and assembly drawing. Okay, in production drawing, we can get for example, for one component, we can get on full assembly drawing. This is the screw jog full assembly view. Here they mentioned part numbers. This is the part 1, this is the part 2, this is part 7, and this is the part 3. And the next video, next picture, this is the part 4 and part 3, sorry, part 5 and part 6. Okay, and this assembly drawing having a total 7 parts having. Uh, okay, this is the component drawing. This is component drawing or product drawing. This is the fully assembled drawing. Okay, and next one is we can interrupt the drawing into single parts. Okay, this is the part drawing. Okay, this is the 7 parts are assembled used to assemble this screw jar. These 7 individual parts are detailed in this part drawing. This is the part 1. Okay, that bill of material also you can see, and this is the casting. This is the part name is casting, and second one is second part is nut, and third one is screw, and fourth one is cup, and fifth one is washer, and sixth one is set screw, and seventh one is dummy bar. Okay, each components are used in one single unknown quantity, and the material of the component is cast iron, gunmetal, mild steel, cast steel, mild steel, mild steel, mild steel. Okay, in every drawing you can give the bill of material of the in every component, sorry, every assembly or every component, you will give the bill of material of the um, part, sorry, individual parts. In that you can represent the how many parts are used in that product or assembly. We can clearly describe that. Okay, part name, and in and that individual part, how many times used in that product. Okay, here for in the symbol drawing, you will use only one time in every component here. Okay, so a quantity is 111. Sometimes nut and bolts and screws are used in multi times in assembly. So for that purpose we will increase the quantity, and also mention the material of the object also. Okay. This is what introduction of AutoCAD and drawing drawing size. I hope you understand and clearly you can get the idea about the drawing. What is the drawing? What is the dimensioning? What is the standards used in worldwide and India? Okay, what is the fit? Different types of fit and different types of tolerance and geometrical tolerance and tolerance. Uh, okay, you may get the idea. Okay, this is about basics of engineering drawing and CAD drawing also. Okay, thank you, students. Thank you so much.